Welcome. Today we are going to talk about how to find side lengths of a right triangle using trigonometry. So here is a right triangle. It's drawn to scale, carefully measured. It's got lots of things marked. We know all of the angles. We know all of the sides. Now think back to the sine of an angle is always the ratio of the opposite side over the hypotenuse. So when we compare that idea to this triangle, the hypotenuse, remember, is always across from the right angle, so the hypotenuse is 2. Then the opposite side is in reference to our angle. So angle A is at the bottom left corner, making our opposite side 1. So the sine of angle A is 1/2. With what we have written here, though, we know that angle A is 30 degrees. So really, the sine of 30 degrees is 1/2. Now this will always be true because if we have those same sides and that same angle, it would be a similar triangle and the ratios will be the same because the sides are proportional. So the nice thing now is that you can use your calculator. If you know the angle that's available, you can use your calculator to see what the sine ratio should be. Now, just as a reminder, 1/2, like our sine of 30 degrees is 1/2, is going to show up as 0.5 on your calculator. The first thing to do is make sure your calculator is in degrees mode. I recommend doing this in every session, especially if you're using a calculator on a mobile device like an iPad or a phone. This is very, very important. It's so important, we're going to have a little slide here with some examples of calculators and how to look and see if they're on their degrees mode. So first I have a Desmos calculator, then the iPad free calculator, the TI-84, and then the TI-30XS. So these are all graphing calculators or scientific calculators, but you have to make sure you see that little DEG or the degree highlighted. Once you've established that your calculator is in degrees mode, find your trigonometry function buttons. Likely they're all in a row or column together somewhere. You're looking for sin, cos, tan, representing sine, cosine, and tangent. Now test out sine of 30 degrees on your calculator. Make sure you know how to input it so that your calculator will show you an answer of 0.5. If you have trouble getting your calculator to tell you that the sine of 30 degrees is 0.5, do a quick Google search about your calculator, ask your math teacher, whatever it is you need to do to get that figured out, because nothing else will work if you can't input things correctly to your calculator. We're going to try some calculator exercises just to make sure that you are able to use the right inputs and get the right answers. Now, just so you know, though, these will not come out to nice decimals. We're going to keep 3 decimal places in your answer every time you use these trig functions on your calculator. So here are some examples: the cosine of 27 degrees, the sine of 74 degrees, and the tangent of 10 degrees. That'll give you a chance to try out all 3 buttons. Go ahead and pause the video, see what your answers are for these. So the cosine of 27 degrees should have come out to 0.891. The sine of 74 degrees should come out to 0.961. And the tangent of 10 degrees should come out to 0.176. How did you do? Where we actually use these is to solve for missing side lengths of right triangles. For example, here's a triangle. We know one of the sides is 14, but we're looking for the other side. Now, unfortunately, we cannot use Pythagorean theorem here because for Pythagorean theorem, you need 2 sides and then you can find the third, but we only have 1. We do have an angle though. So here are some steps you can take. Step 1, identify your reference angle. This has to be one of the acute angles. You cannot use the right angle with what we're doing. So 67 is our reference angle here. Step 2, we're going to label the sides that we care about. I don't say the sides we're given, I say the sides we care about, with either hypotenuse, adjacent, or opposite, based on that reference angle. Now, the reason I say the sides you care about is because, for example, that x equals question mark, we aren't actually given that side, but we do care about it because we want to know how big it is. So we'll label that side. That would be the opposite side from our angle. And the 14, of course, we're given that information, so we do care about that one, and that's our adjacent side. Step 3, based on what we have, we care about the adjacent side and the opposite side. We're going to decide which trig function to use. So just as a refresher, the sine of your angle is the opposite side over the hypotenuse. Cosine of your angle is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Now looking at what we have the opposite side, which means it's either going to be sine or tangent. It's definitely not cosine because that doesn't use the opposite side. Then the other side that we have is the adjacent side, which leads us to the tangent, because sine doesn't use adjacent, even though it does use the opposite. So we'll be using tangent. Step 4 then is to fill in your values and then solve for the unknown. Now remember, the tangent of A, that A represents your angle measure. So sometimes you'll see it as theta, we had it as A here, but it represents the angle. Your trig functions are always functions of an angle measure. So tangent of 67, and then our opposite side was x, so we fill that in. Adjacent side was 14. Now to solve this, we'll multiply both sides by 14. So the 14s cancel out on the right-hand side, giving us just x on the right. Now when we do 14 times tangent of 67, if you would like to use your calculator and find the decimal equivalent of 67, a tangent of 67 first, go for it. Tangent of 67 should come out to 2.356. Then we'll multiply by 14, and that's our answer for x. So here's an example that I'd like you to pause the video and try on your own. So we have one side that we're given, one side that we're trying to find, and we are given an angle. So we're going to use those 4 steps to solve for y. So remember, step 1, identify the reference angle. Step 2, label the sides. Step 3, decide which trig function is applicable. And step 4, insert your values and solve. So go ahead, pause the video and see how far you can get. Step 1, as we identify the reference angle, we're only given one acute angle, so that will likely be your reference angle. Then step 2, to label the sides. The 11 would be our adjacent angle. The y is our hypotenuse. Step 3, decide which trig function is applicable. We have sine, cosine, or tangent as our options. But since we are caring about the adjacent side and the hypotenuse, we'll be using cosine. Then step 4, insert your values and solve. So we are finding the cosine of 28 here, 28 degrees. Our adjacent side is 11, and our hypotenuse is the y value. But now our y value, our unknown, is in the denominator, and that will freak a lot of people out. Don't worry though. All we have to do is go back to our basic algebra steps. We can get y out of the denominator into a place that we like it a little better just by multiplying both sides by y. The y's on the right-hand side will cancel out, leaving us with y times cosine of 28 equaling 11. Then to get y by itself, we just need to divide by the cosine of 28. So the cosines on the left side will cancel out, leaving us with just y on the left. And here again, if you like, you're welcome to find the decimal equivalent of your cosine of 28, which would come out to 0.883. If your calculator can handle it though, it's always better to do that division step all in one. So actually type in 11 divide by the cosine of 28, and you should get an answer that rounds to 12.5. So to summarize, we found 4 steps that help us find side lengths using trigonometry. Step 1, identify your reference angle. Step 2, label your sides. Step 3, decide which of the 3 trig functions is applicable in your scenario. And then step 4, insert your values and solve. Thank you for joining me for this Intro to Trigonometry lesson, and I'll see you soon.